In this process, we cover the surface with a photo-imageable ink called solder mask. The ink provides protection where needed and can be removed where we don't want coverage, such as in areas where components will be soldered. The solder mask also protects the copper, preventing oxidation, and provides insulation for the circuitry. First, we need to prepare the copper surface by roughening it for better adhesion of the liquid solder mask. This can be done through mechanical brushing with pumice and/or a chemical etching process. Etching is good for fine tracks that could be damaged by mechanical roughening alone. After roughening, the surface is rinsed and dried to prevent copper corrosion. Next, the liquid solder mask is applied using either a silkscreen or spray coating process, depending on the factory's setup, technology requirements, and solder mask type. In this case, we observe screen printing, where the liquid solder mask is deposited on one side of the PCB, the panel is then flipped, and more solder mask is printed on the second side. Since we can't handle a panel covered in wet ink, we pre-cure the deposit of liquid solder mask slightly. This process hardens the outer layer of the solder mask, making it handleable. We check and approve the solder mask inks used by the factory, ensuring they comply with Class T of the IPC specification SM840. In line with our own demands, we specify the thickness range of the solder mask needed on the PCB, not just on the surface but also on the knee of the track. This ensures a reliable coverage of ink. All these aspects are thoroughly checked and reported in the NCAB C of C.